Okay, Secondary Math 1 class. Today we are going to be starting a new unit, but we're building on concepts we've already learned, which is good. Okay, so today we are going to be talking about distributing, okay, the distributive property. Okay, so we are going to be working with mainly expressions, okay? Expressions are math sentences that don't have an equal sign, right? So we're not solving for anything, we're just simplifying things, okay? So let's look at numbers 1 through 4. Okay, so let's read our instructions. It says, simplify each expression by combining like terms, okay? Well, first, let's review what a like term is. Okay, in order for something to be a like term, it has to have the same variable. Okay, and I'll even add in parentheses, or no variable at all. Right? It either has to have the same variable or no variable. And 2, it has to be to the same power. Okay, so that variable has to be to the same power if it has one, right? If it has an x, it has to be x to the first power, and x to the first power, or x squared and x squared. Okay, so think same variable, same power. Okay, so let's look at number 1. We're going to go ahead and simplify this expression by combining like terms. So let's look at our first term. That's this 4a. So does this term have a variable attached to it? Yes, it does. It has that a. Okay, and this a is to the power of 1. Okay, so we're looking for another term with a to the power of 1. Okay, we'll look at our second term. Does this also have an a to the power of 1? Yes, it does. Okay, so this is like saying I have 4 a to the power of 1s, and I'm adding 2 more a to the power of 1s. So what is 4 plus 2? Okay, that's going to give me 6. Okay, and then all you got to do is add your variables. Okay, a to the power of 1 is just a, right? We don't have to write that 1 on our a. Okay, so that is simplified. Okay, we simplified it by combining like terms. Okay, let's look at number 2. So our first term is 3n, or 3n to the power of 1. Okay, so we're looking for n to the power of 1. Okay, let's look at our second term, 2n to the power of 1. Are these guys like terms? So they have the same variable, and are they to the same power? Yes, they are. Okay, they both have n to the power of 1. So we can just say, what is 3 minus 2? Okay, that's going to give me 1. Do we have to write the 1 in front of our n? Right, this is saying I have 3 n's. I'm subtracting or taking away 2 n's. I have 1 n. Okay, because we don't have to write that 1, it is just n. Okay, number 3. Okay, so notice this time we have 1, 2, 3 terms. Okay, so we need to figure out which terms are alike, which terms can I combine. So let's look at our first term. I just have 1x to the power of 1. Okay, do you guys see any more x to the power of 1s? No, this negative 3 doesn't have an x, and the 4 doesn't have an x. So there's nothing I can combine with that x. It's just going to stay 1x. Okay, but now let's look at negative 3 and 4. Okay, notice in order for it to be a like term, it either has to have the same variable or they both don't have variables. So look at 3 and 4. These guys both don't have variables, so they are like terms. So now this is just saying, what is negative 3 plus 4? Okay, we can combine that to give us what is negative 3 plus 4. I owe you $3, but I give you $4. How many extra dollars did I give you? 1, so positive 1. So our answer, our simplified expression, is going to be that x that we couldn't combine with anything, it just stayed x, and then a positive, so plus 1. Okay, awesome. So now let's look at number 4. Okay, so we have two terms in number 4. Let's look at our first term. So we have negative 2p, this p is to the power of 1. Okay, so we're looking for another p to the power of 1. Does our second term have p to the power of 1? Yes, it does. So that means these guys are like terms. I can combine them. So now we can just say I have negative 2 p's, and I'm adding 8 of them. Okay, how many do I get? What is negative 2 plus 8? That is going to give me a positive 6, and then add your variable. So positive 6p to the power of 1, which is just 6p. Beautiful. Okay, awesome, you guys. So now let's look at the rest of our expressions. So this is where the distributive property comes into play. So let's actually write that. Okay, we're going to be using the distributive property to simplify these guys. Okay, a big hint that we are going to have to distribute something is when we have parentheses. Okay, these guys right here. Okay, so whenever you see parentheses, more like 90% of the time, you're going to have to distribute something. Or there is 100% of the time, there actually is being something distributed, even if it's just a 1. Okay, so whenever we see the parentheses, we always have to look for what is the number in front of the parentheses. Okay, so what is the number right in front of my parentheses? It's this negative 4. Okay, so think of it like this. Negative 4 is on the outside of the house, and it wants to come play or hang out. You guys are high schoolers, I guess. Wants to come hang out with both things in the house, in the parentheses. So it wants to come into the house and hang out with both these guys. Okay, well, what is it actually doing when it comes into the house? Are we adding that negative 4? Are we subtracting it? What are we doing? Okay, we are multiplying. Okay, it's the same thing if we were whenever you have something like this negative 4 and it's right next to something else, okay, meaning it's right next to these parentheses, it's being multiplied. Okay, so we now have to multiply to both things inside, right? It wants to hang out with everybody inside the house. So first we take, what is negative 4? We're multiplying by 1. Okay, what is negative 4 times 1? It's going to give me negative 4. Okay, but now we have to multiply it to our second term. So what is negative 4 times positive 9n? Okay, don't freak out that there's a variable here. Okay, I'll show you how to just add it on at the end. First, let's look at what is negative 4 times 9. What is negative 4 times 9? Okay, it's going to be negative, right? Because a negative times a positive. 4 times 9 is going to give me 36. Okay, and then with the n's or the variables, you just say, okay, how many n's were being multiplied? Just one n. Okay, so I'm just going to put 1n, or n to the power of 1. Okay, so now what we need to do is we need to rewrite these guys by actually combining them. These are just pieces of our expression. Okay, so we're going to write it negative 4 minus 36n. Okay, and our very last thing we have to do is check and see if we can simplify it any more. Okay, so now once we've combined them, you have to see, are they like terms? If they are, then we need to simplify it some more. But look at negative 4 and negative 36n. Okay, one has a variable and one does not. Okay, so are these guys like terms? No, they are not. So our simplified expression is just negative 4 minus 36n. Perfect. Okay. Let's look at number 6. First thing we need to identify is what is the number right in front of our parentheses that needs to distribute inside the parentheses, okay? It wants to come inside and hang out with everything inside, right? So that is going to be that 9. Okay, the 9 is right in front. It wants to distribute, okay, which really means what? Multiply to everything inside. Okay, so first let's take our 9 times 5. So 9 times 5. What is that going to give me? 45. Beautiful. Okay, and then we have our 9 times negative 4r. You must include that sign. It's a negative 4r. Okay, so let's take the 9 and the negative 4 first. So I have 9 times negative 4. What is that going to give me? It's going to be a negative. Okay, 9 times 4 is 36. And then I had 1r that was being multiplied, so just 1r. Okay, now that these are just pieces, right, we have to combine them, write them out together. So we had a positive 45, so 45, and then a negative or minus 36r. Okay, and again, now we have to ask, are they like terms? Okay, if they are, we need to simplify it a little bit. Okay, so let's look at 45. That one doesn't have an r attached, but negative 36r does. So are they like terms? No, they are not. So we cannot combine them. So that is as simplified as it'll go. Okay, so our simplified expression is 45 minus 36r. Beautiful. Okay, let's look at number 7. Okay, so find the parentheses. Okay, I see parentheses. And what is the number right in front of the parentheses? The number that's going to have to distribute into them. Okay, again, it's going to be this 9, positive 9. So that 9 wants to come inside and hang out with everyone inside. Okay, so meaning it needs to multiply to both things, both terms inside our parentheses. Okay, so let's take the first term. So we have 9 times 10. Okay, what's that going to give me? 9 times 10. It's just going to give me 90. Okay, now let's take our second one. The 9 has to multiply by positive 7a, so 9 times 7a. Okay, let's look at the 9 and the 7 first. What is 9 times 7? I'm actually going to double check this on a calculator. Okay, that's going to give me 63. And then 1a was being multiplied, so just 1a. Okay, so those are our pieces to our expression. Now let's rewrite them together and then see if they're like terms. Okay, so we have 90 and a positive 63a, so plus 63a. Okay, so now we can ask, are these guys like terms? Can I combine them? Can I simplify them anymore? So the 90 does not have an a, but the 63 does have an a attached, so they are not like terms. So that is as simplified as it'll go. Good job. Okay, let's look at number 8. Okay, find the parentheses. The parentheses tell us that we're going to have to distribute something, right? So what is the number right in front of the parentheses that we're going to have to distribute? It's going to be this negative 10. Ooh, now we're dealing with a negative, but that's okay. We've dealt with a negative before. Okay, let me focus in. There we go. Sorry, it wasn't focusing. Okay, so we have this negative 10. Okay, it wants to distribute, meaning multiply to both terms inside. It wants to come in and hang out with everybody inside, right? So let's take negative 10, multiply by our first term, which is 6n. Okay, so what is negative 10 times positive 6? That's going to give me a negative. Okay, 10 times 6 is 60. And then there was 1n being multiplied, so just 1n, negative 60n. Okay, now let's take negative 10 times negative 9. Okay, what do we get when we multiply a negative times a negative? It's going to give me a positive, right? So what is 10 times 9? It's going to give me 90. Okay, so we multiplied by everything inside. Now we just need to rewrite them together in our expression. So this is going to be negative 60n plus, because it's a positive, 90. Okay, now our last step is to ask, are they like terms? Do we need to combine them anymore? So I see that the negative 60 does have an n, and then the 90 does not. Okay, so are these guys like terms? No, they are not, so that is as simplified as it will go. Beautiful. Okay, let's look at 9. This one is weird, okay? So this is kind of a tricky question, what I'm about to ask you. What is the number, so find your parentheses first, but what is the number that is right in front of the parentheses? Right in front. Okay, you might think that it's this 2k, or you might have even thought negative 2k. But the number that is right in front is actually negative 1. Okay, so our negative 1 is actually right in front. Okay, so we're going to do the same thing like we did on 7, all those ones. It's almost like we're going to just ignore this 2k for a minute. Okay, so in fact, I'll write that. Ignore, whoa, I did 2 I's. Ignore for a sec. Ignore until the end. Okay, so your first step always is to get rid of the parentheses, meaning you must distribute before you combine like terms. In fact, that's a super important rule. Let's write that on the bottom of our paper. So let me zoom out a little bit. Let's write that right at the bottom. Let's star it. Must distribute before you combine like terms. You must get rid of the parentheses first. Okay, so you must distribute before you combine like terms. Okay, so let's look back at number 9. Okay, so we got to distribute. We got to get rid of these parentheses. Okay, so we figured out that it's actually a negative 1 that wants to come into the parentheses and hang out or multiply. Okay, so let's take negative 1 times first term, which is 3k. Okay, so we have a negative 1 times 3. That's going to give me a negative 3. And then 1k was attached, so just 1k. Beautiful. Okay, now let's take negative 1 again times positive 8. Okay, so what is negative 1 times positive 8? It's going to give me negative 8. Okay, so now we got rid of the parentheses. Okay, so let's just rewrite it. Okay, just like we were doing up top. So we're just going to rewrite it, put them together, okay, to create. So we had negative 3k minus 8. Okay, so this is where we need to bring down this 2k. It's like this 2k was just kind of waiting patiently. Okay, so we have a positive 2k that was out in front. Now we have negative 3k minus 8. Okay, so notice we distributed, and now we can combine like terms. Okay, so in fact, I'll write that. Let's write that as steps. Okay, so our first step was to distribute. Wow, I'm struggling on spelling today. Distribute. Okay, and our second step that we're going to do right here is to combine like terms. Okay, and we already made that note that we must distribute before we combine like terms. Okay, so your first step is to distribute. Your second step is to combine like terms. So let's look at 2k minus 3k minus 8. Where are my like terms that I can combine? So let's look at our first term, 2k to the power of 1. So I'm looking for another term with just 1k. It's going to be this negative 3k. Okay, so if I have 2 minus 3, what is that going to give me? Negative 1, and then there was that k, so negative 1k. And then can we combine negative 1k and minus 8? No. Okay, so we can just bring down that negative 8. Those guys are not like terms. Okay, so that is as simplified as it'll go. So our simplified expression is negative 1k minus 8. Okay, because the only two terms that we could combine when we're combining like terms was that 2k minus 3k. 2 minus 3 is negative 1. We had that k. With the negative 8, you just bring down. Alrighty. Okay, so let's look at 10, our very last example. So this one is a little different because now how many sets of parentheses do we see? Okay, I see 2 sets of parentheses. I see these parentheses and I also see these parentheses. Okay, but our steps are going to be the exact same. We must distribute before we combine like terms. Okay, so let's just take it one set of parentheses at a time. Let's look at this first set of parentheses. So ignore the second set. Okay, so what is the number in front of that first set of parentheses that wants to distribute into the parentheses? It's going to be this negative 9. Okay, so it wants to distribute, meaning multiply, to both those guys inside. So we have negative 9 times 9. Negative 9 times 9. First, what is that going to give me? Negative 9 times positive 9. It's going to give me negative 81. Okay, then we have a negative 9 times negative 10m. So we have a negative multiplying by a negative, which is going to give me negative times a negative. It's positive, so 9 times 10, 90. There was 1 m attached to that, so 90m. Okay, we're just going to leave those for just a second. Okay, so we'll say that that was our first set. That's our purple set. So let's do our green set over here. So look at our second set of parentheses. What is the number that needs to distribute or wants to come inside the parentheses? Okay, it's that 3, right? And it's going to distribute, meaning multiply, by both things inside. Okay, so we get a 3 times 8 is our first term. So what is 3 times 8? It's just going to give me 24. Okay, and our second one is 3 times negative 10m. So 3 times negative 10m. What is that going to give me? Okay, so we have a positive timesing by a negative. So we get negative 3 times 10 is 30. There was 1m being multiplied, so 30m. Okay, so we have all of our pieces, right? Negative 81, 90m, 24, negative 30m. Okay, so now our next step is just rewrite them all together. Write all together, just like we were doing up here, right? We have all the pieces, just write them together. Same thing, now we just have 4 pieces. So I'm just going to rewrite them. So I have negative 81 plus a positive 90m. Okay, plus a positive 24, and then a negative 30m. Okay, so we rewrote them all together, and now we can combine our like terms. So we distributed and got rid of our parentheses. We have no more parentheses. Now we can go ahead and combine like terms. Okay, so let's look at our first term. Let's look at 81, negative 81. Okay, so negative 81 doesn't have any variables attached, doesn't have an m attached. So what is the other number you see that doesn't have an m attached to it? It's going to be this 24, right? So what is negative 81 plus 24? Okay, negative 81 plus 24. You can always use your calculator. Negative 81 plus 24. That's going to give me negative 57. Okay, let's find our other like terms. Okay, so our second term is this 90m. Okay, so do you see any other terms with an m, just m to the first power attached? Yep, so we have negative 30m. So what is 90m minus 30m, or 90 minus 30? What is that going to give me? It's going to give me 60m. Okay, and since we already combined like terms, all we have to do is just rewrite them together. So negative 57 plus 60m is our final simplified expression. Okay, they are not like terms, right? One has an m, the other does not, so we know we are all the way simplified. Okay, those are your notes, you guys. Make sure you do your assignment below, and you are awesome.